students, today in this video we will solve one question from nuclei. This type of question comes in the board exam, and it has already this question is a previous year questions from your CBSE board exam. So here binding energy per nucleon is asked to calculate, and what is given? The nucleus, the mass of the nucleus is given, that is in atomic mass unit, or U simply you can say, mass of neutron, mass of proton, all these are given data. You have to find out the binding energy per nucleon. So what is binding energy per nucleon? For that you have to first find out the mass defect, because binding energy is delta m mass defect into c square divided by binding energy per nucleon binding energy per nucleon is equal to mass defect multiplied by c square, that is your binding energy, and mass number. If you divide the number of nucleon inside that nucleus, so it will be binding energy per nucleon. So here what is our delta m mass defect? Mass defect is the sum of the individuals nucleon, the mass of all the nucleon subtracted by the mass of nucleus. That means sum of the individual masses of nucleon. So what are the, how many nucleons are there? Nucleon mean proton neutron together called nucleon. Proton और न्यूट्रॉन दोनों को न्यूक्लियन बोलते हैं. तो how many nucleons are there? 40 nucleons are there. Out of that 20 is the atomic number. So proton is 20, neutron is 40 minus mass number minus z, atomic number is your neutron number. So how many neutrons are there in this calcium atom? ये कैल्शियम एटम में 20 प्रोटॉन है और 20 न्यूट्रॉन है. ठीक है, तो एक प्रोटॉन मास ऑफ 1 न्यूट्रॉन इज दिस, सो वी कैन मल्टीप्लाई 20 हियर. तो डेल्टा एम क्या करेंगे? हाउ विल यू फाइंड डेल्टा एम? डेल्टा एम इज द सम ऑफ द मास ऑफ 20 न्यूट्रॉन प्लस सम ऑफ मास ऑफ 20 प्रोटॉन subtracted by mass of calcium 2040. This is your delta m, and we will multiply a c square with here delta m, and we will divide a, means here atomic mass is 40. So this is what we will do. So first find out the numerator. So 20 into mn plus 20 into mp, basically 20 we can take common, mn plus mp minus this we can do. So here is the numerator, we will calculate here. So 20 neutron, mass of 20 neutron, 1 neutron mass is 1.008665 AMU. So if we multiply 20, this is the number, right? 20, and mass of proton is this. If we will multiply 20, because 20 protons are here, so we will multiply 20, so 20 proton. Now add it, mass of 20 proton plus mass of 20 neutron, 40.329800. Now total mass of the calcium nucleus is 39.962589, it is given. Now we will subtract it. This is the mass of neutron plus mass of proton. We will subtract the mass of the nucleus. The difference is the mass defect. So this is the delta m we are getting. Mass defect is 0.367211 AMU, and we know that 1 AMU is 931 MeV, mega electron volt. How will you do that? 1 U is basically 1 AMU is your 1.67 into approx 10 to the power minus 27 kg. This is 1 AMU. Now you can convert to energy by multiplying C square. So this multiplied by C square, and then how will you convert to EV? Divide by 1.6 into 10 to the power minus 19. So when you will divide that, you will get approximately 931 into 10 to the power 6 EV, and 10 to the power 6 is mega, so you will get approximately 931 MeV, that is energy of 1 AMU. 1 AMU, atomic mass unit, 1 AMU is 931 MeV. 931 MeV. So we are getting 341.87 MeV. We are getting this mass defect, multiply in AMU, right? This numerator is the mass defect that we are getting this, and this mass defect we are multiplying with this. If we multiply C square, then 1 AMU we can convert using this conversion 931. So we are multiplying 931 to convert this AMU to energy, right? By multiplying C square we will get this, number. Then this MeV we have to divide. We are supposed to find the binding energy per nucleon. तो बाइंडिंग एनर्जी तो मिल गया, उससे फिर मास नंबर उसको डिवाइड कर देंगे. कैल्शियम के लिए मास नंबर 40 है, तो 40 डिवाइड कर देंगे तो हमें मिल जाएगा बाइंडिंग एनर्जी पर न्यूक्लियन. तो 341.87 MeV divided by 40, so 10, it will be 34, so 4 you can write 4 8 ja 32 and 21, 4 5 ja 21, then point this is 8, 4 1 ja or 4 2 ja 8, 7, 4 1 ja 4, 330, 4 6 ja. So 8.5216 MeV is the binding energy per nucleon. This is EBN, binding energy per nucleon we will get for calcium. So it's 8.216 MeV. So I hope the question is clear, and how to approach the question, how will you solve that. I think it's clear. Any confusion, any doubt, you can ask in the comment section, so that in my next videos I'll try to clarify them. Thank you for watching, and for the board examination 2024 we will be solving some of the important questions that like previous year already this type of question has come from chapter. Each chapter will try to cover many questions. So subscribe to the channel, right? Thank you for watching. See you in the next video.